Hello and welcome to another round of OAuth Happy Hour. Oh, there we go. I am Aaron Parecki and I'm here with Lee Brandt today. So good to see you here. Thank you all for joining. We are going to have a chat and just talk about OAuth things. So feel free to drop questions in the chat if you are watching live. Otherwise, you can comment on the video and we'll answer questions later in the comments too. So what's new in your world, Lee, for OAuth things? What have you been thinking about lately?
Well, I'm interested in, I was looking through the sessions for Octane, and I'm really kind of interested in, Brian Demers is giving a talk on JWTs, Passetto, and something else. He named a bunch of stuff, but he also did a little oh my at the end, so I can't tell which ones are real and which ones aren't. Um, so I was just wondering about like OAuth and can you generate Passetto tokens, or is it always just JOTs, or can you decide what type of token you want to generate?
Yeah, that's a good question. I guess let's back up a minute. And first of all, what is a Passetto token? Can you tell me?
No, I just know it's a new type of token format.
Okay.
And I just know that Ryan wrote the Java library for it. So
Got it. Yeah, I don't know actually too much about Passettos other than what I've seen in like Randall's talks and blog posts. He's done some blog posts about that. But it's, I guess, an alternative format to JSON Web Token, which is supposed to solve some of the problems of JSON Web Tokens, which are, you know, I guess mostly problems with misusing JSON Web Tokens. So I guess they're trying to make it so that it's harder to misuse them, right? But yeah, it's I don't know how widespread it is in terms of uses in the wild, but I've seen some interesting blog posts and stuff about it. So JSON Web Token, of course, is a very common format for OAuth access tokens, probably because it is the format for ID tokens. So the OpenID Connect adds in ID tokens on top of OAuth, right, to talk about users. That was kind of where JSON Web Tokens came from. And then because it's a convenient format for packaging up JSON data and signing it, it ended up being like an appealing format for when OAuth servers were implementing access tokens. So this is all to say that OAuth itself does not care about access token formats. There is no rule. It can be anything. It can even be no format. It can just be a random string. And you do see the random string tokens in plenty of APIs. So GitHub, for example, just uses random strings. And a lot of services use random strings because it's simple and there's also some advantages too. But JSON Web Token is also a common format that is used because there are also advantages to JSON Web Token format access tokens. But yeah, there's no rules in OAuth. You can do whatever you want, and you can, as long as your resource servers or your APIs know how to validate access tokens, they can be in whatever format you want.
I got you.
Yeah, so you absolutely could use Passetto tokens for access tokens if you wanted to. Cool. But yeah, I don't know if I don't know if there's any OAuth servers in the wild that actually do support Passetto tokens for access token formats in particular.
Well, and all I know about it so far is that it stands for Platform Agnostic Security Tokens. But it's supposed to be a secure alternative to the JOSE standards, JWT,
Right.
JWE. I didn't even know there was anything besides JOTs, so I'm way behind the curve on what access tokens there are.
Yeah, well, the JOSE was a JSON Object Signing and Encryption. I think that's what that stands for.
Okay.
It's a family of specs, and they do different things. JSON Web Token is the concept of a signed JSON object. So that's where the signing comes in. JSON Web Tokens are not encrypted. That would be using JWE. If you were using JWE instead of JWS, that would be an encrypted token.
Okay.
And JSON Web Token then also adds in like vocabulary. So it'll be like, here is a property name for the timestamp that this token expires. And that's where that kind of stuff is described. So it's like they're all little building blocks, right? Where the most generic, like outermost layer is just the part of like make a JSON document, and then here's how to create a header, create your payload, and create the signature. And that spec doesn't really care about what's inside of it. And then JSON Web Token goes and says, here's specific things that need to go into this object in order to be a JSON Web Token. But yeah, it's all just, it's because of the way the specs are usually written to be sort of modular like that. That's why it's broken up into all these different parts.
Nice. But OAuth doesn't necessarily care how you're presenting an access token.
Yeah, sorry, you were breaking up, and I'm wondering if that's coming through, if it's just my computer glitching, or if it's
I don't know, it could be
on the stream too
as well. So OAuth itself doesn't really care or prescribe any token type. It doesn't care how you're transferring access tokens or transmitting access tokens.
Yeah, exactly. So OAuth just says the OAuth server is going to issue an access token, and the access token can be in any format and contain anything you want, or just be a random string. And the client doesn't need to know at all about the format either, intentionally. It's actually a very clear design decision that went into OAuth, was make sure that the clients do not need to know or worry about the format of access tokens. They should not be able to look at them or interpret them. And the part that does need to know about the access token format is the resource server, or the API, because that's the one that the token gets sent to go fetch data or modify data or whatever it is.
To do Auth Z type stuff, right? To say, yes, you are authorized to actually do this.
Uh-oh, completely dropped out. Okay, this isn't good. I literally didn't hear the whole sentence you just said.
Oh.
Anybody who's watching, can you tell us if you can hear Lee, or is he dropping out for you as well?
Yeah, because on my end, it's nice and smooth.
Yeah, it could just be my computer freaking out. I should be able to see your comments in the chat. Brian says he can hear Lee. Okay, yeah, they can hear us both. So okay. It's just on my end. That's not good. How can I fix this? It's probably my AirPods, and I don't have other headphones to plug into my computer. What am I going to do? I'm going to uncheck stereo audio. Sorry about this, technical difficulties. You know, I have to say, I like my M1 Mac Mini, but I don't feel like it's blowing me away the way that everybody said it would.
Yeah, I got one to try, and because I do a lot of video editing, and it doesn't seem to handle HD or 4K footage any better than the Mac Pros with the Intel chips in them. So I don't.
Yeah. Okay. Yeah, my headphones are completely glitching. So let me just reconnect my headphones.
Okay.
Oh, you know what? I bet if I use my computer speakers and just turn it down, we might not get feedback. Okay. We'll try this for a little bit.
Cool.
Anyway, sorry. What were we talking about? We were talking about...
we were talking about tokens and the signature for tokens and the fact that the authorization server that sends it doesn't care what type of format for the token, as long as the resource server can read it and validate that it is actually a valid access token before giving you whatever resources you're asking for.
Yeah. Okay. Exactly. So the yeah, if you wanted to, so the client doesn't need to know about token format intentionally, which also means that as long as your resource server and authorization servers are coordinating, they can change the token format at any point, and it doesn't matter. So you can decide to be sending JSON Web Tokens today, and then switch to Passetto tokens if you wanted to. And you don't need to rewrite any client code because the clients don't care about token formats. They just are going to be getting strings, treat it as a string. They get a string and then send that back up to the resource server. So your resource server needs to know whether it's a Passetto or JSON Web Token and how it's going to validate that. But as long as your resource server is, paying attention to the decisions they're making around your token formats, then yeah, it'll all work just fine.
Nice. So I was going to ask you more questions about Passetto, but it sounds like you probably know about as much as I do about the format and why somebody.
Well, I mean, we can go and we can go dig up the websites if we need to.
I know
I have done a little bit of
Passetto.io, but
what was that?
I know the Passetto's on Passetto.io, but it looks like the homepage is just all the libraries for Passettos and conference talks and stuff like that. It doesn't really say anything about what it is or what the format actually is.
Let's see. Here is the Passetto website. Oh yeah, all the implementations. I thought there was a website that talked about the.
You can see the RFC. There's a link to the RFC, but
maybe it's this one. Maybe it's this implementer's guide that I'm thinking of. Because I do remember seeing something about the format too. Yeah, here we go. This is what I remember seeing. It's on their GitHub. So it's so it is right. It is just a similar encoding of JSON data with different ways of assigning it. And I remember the local versus public thing. So that was that is a public signature, it's asymmetric crypto versus shared key. And that's JSON Web Tokens have a similar thing. I think you can encrypt a JSON Web Token with a shared secret, which would be the HS256, or you can sign a JSON Web Token, or you can sign a JSON Web Token with asymmetric cryptography, RS256. So same ideas. This is the important part, because they work actually very similarly, right? They're both signing JSON data, but I feel like almost are trying to, I don't know. I feel like it's trying to find a problem, solve a problem that is marginally a problem, if that makes sense. It's not a huge problem. Like there are, ways to misuse JSON Web Tokens of, like, for example, not signing them. You can have algorithm none, which is technically a valid JSON Web Token. But then there's no signature, which is kind of a weird overloading of the term JSON Web Token. But technically it works, and that's not safe to use for almost anything. So they're like not letting you do that in Passetto, right? But I don't know.
Yeah, I mean, it
I think
looks
I'm
like
not as much of a fan of it as other people are.
yeah. No, I mean, looking at Randall's post on Okta,
Oh
it
yeah.
looks like the 4 sections are the version, the purpose, whether it's local or public, and then the payload, and then an optional footer, which the footer usually has the signature, right? That tells you how to unencode it or
In a JSON Web Token, the footer is the signature, but I think that's not the case um, in Passetto, right?
yeah. Yeah, it
Yeah.
looks like
Anyway,
it's
I want to know more about why Passetto is so much better than JSON Web Tokens.
yeah.
Um, other than it's slightly harder to get it wrong, which is, as far as I can tell, the main difference. Maybe Brian has some feelings about this, since he says he hearts Passetto in the chat.
Yeah.
Anyway,
Excuse me.
yeah, as far as OAuth goes, go for it. Like, if your OAuth server can support arbitrary token types, there's no reason you can't use Passetto as your access token format.
And one of the things that I came across in my little search was the fact that Okta now supports Passetto.
Wait, Okta supports Passetto?
It looks like one of the articles that I saw, Okta offers Passetto as alternative to JSON tokens in DevOps on DevOps.com.
I did not know that. Please share your screen.
July 23 of last year. Let's see.
This is news to me.
Share screen. Application window is all I want to share. Share that.
Is it working?
Well, I think I have to go over here, and every time I do this, I don't know if it's a Big Sur thing, but I have to go in and allow Chrome.
Oh, right. Allowing Chrome to share the screen means restarting Chrome. Okay, I hope Lee comes back. Anyway, in the meantime, if you have questions in the chat, or please drop them in the chat and we'll take a look at them. Oh, okay. I see. Brian says, no, Okta supports Passetto, the library. That makes sense. And Lee is back.
Yeah, I had to go and give it permission for Chrome to capture my screen, and then it just immediately quit and restarted.
Right. Helpful.
Don't show these tips again.
So while you were gone, Brian said that we support the library, as in support it as a library, but the access tokens to the Okta issues are not Passetto.
Oh, okay.
Did you find the blog post?
Yeah. Can you see my screen?
Yeah. Yeah. Okay. It's just talking about the library. Somebody must have misreported that headline based on the comment in the project.
So they're just talking about the fact that Brian's working on the Passetto library.
Yeah. Yeah.
Okay.
That makes more sense. I was not aware that we suddenly had more options for access token formats.
Oh, believe me, when I saw it, I was like, okay, I didn't know that.
Yeah. I think it would be interesting to consider that, but it's definitely a big change. And again, the only part of your system that would care about this would be your APIs that are validating access tokens, but your APIs would have to know how to validate these new types of token formats, or always use the remote introspection where you're basically just pushing out the question down to the OAuth server of like, you make that post request to the introspection endpoint, send the token there. It tells you if the token is valid and what information exists about the token. So, but that's network traffic.
Yeah, it seems like there would be a little bit of a problem with, since you have this optional metadata thing at the end, it's more than just, hey, the end part's going to be the signature and the authorization server can handle it. It would be, hey, I want to use Passetto tokens, and here's what I want in my metadata footer.
Yeah, what's the footer for? The metadata? Is that...
Yeah, it looks like it's for anything else you want to add to the token.
But it's not, that's not encrypted.
No.
Yeah, okay. So that's weird. Randall says it's useful for things like key rotation. But like you put whatever JSON data you want into the token itself, and that's the part that gets encrypted, which is useful. Oh, yeah. That's a difference. Is it the case that Passetto tokens are always encrypted?
It doesn't look like it because it's, well, maybe so. And
I think that's true.
Okay. Public Passettos are not encrypted since it is assumed you can't safely share a secret between all parties that will be interacting with the Passetto, but are digitally signed. Well, that's the same as JWTs, right?
Oh, it's the public ones are not encrypted.
Yeah.
Only signed. Okay. So yeah, it seems like, I don't know, it's not that much different than JSON Web Tokens at the end of the day. Because that's one of the problems with JSON Web Tokens is that they are also not encrypted, which means anything that you put into your access tokens, like custom claims, all those claims are visible to the end user and the app developer, right? It's basically encoded, but it's not encrypted. So you can go log into an application, look at the access token and be like, oh, I see it's a JSON Web Token. I'm just going to grab that middle chunk, see what they know about me, see what they say about me, and find sometimes interesting claims inside. Well, example I like to use is, let's say if you're building a system where you want to be able to shadow ban users, which would mean that they don't know that they're banned, but anything they do sort of just goes into the void. So someone like commenting on stuff and it looks like their comments work, the comments show up to them, but nobody else sees their comments, right? So you could implement that with like a flag on the user account in the database, or you could try to push that information down into your access tokens to let your resource servers know that this user is shadow banned without having to go check the database of users, right?
I gotcha.
So you could imagine that you would make a custom claim called shadow ban true false, put that into the access token, and then when your application goes to post the comment, the resource server looks at the access token and says, oh, I can see this access token is from a shadow banned user. I'm going to go and store that differently in the database. Sounds good on paper. The problem is that information is inside the token, not encrypted, which means the user can look at the token and see if they are shadow banned. And the whole point of a shadow ban is to not tell the user that they're in that state. So that's the thing to keep in mind, is that anything you put into tokens is visible to users. So
you just have to rename shadow ban true false to something like double secret probation or something.
Yeah, exactly. Yeah.
They're in the cool kids club, yes or no? If they're in the cool kids club, then they're shadow banned.
Right.
I would love to be able to do that to some of my family members on Facebook, actually.
Yeah. So, okay, Brian in the chat says, Passetto simplifies implementation for library developers and reduces the number of options from 30 different algorithms to 4 combinations, same use cases. So, yeah, it's supposed to be harder to mess up is, I guess, the end of that. So, let's see if I can show the YouTube chat. Yeah. Why is Passetto better than JWT? I guess because fewer options means simpler implementations and less ways that it can be messed up.
Less bullets to shoot yourself in the foot with.
Yeah, exactly.
Well, and definitely if you guys are interested in more of the Passetto stuff, that article from Randall, he has a whole section down below that's the two things that the two problems that Passetto solves.
Yeah, let me share that link in the chats and on the screen. This is the article we are talking about, a thorough introduction to Passetto, and that is the link. Where's the chat? So yeah, it's a pretty good overview. I think it's a pretty popular blog post on our site too. But he goes through I guess this is a good way to think about it. It's a subset of all the things that JSON Web Tokens let you do in a way that is harder to then do things that are bad. I made that picture for Randall. I remember when he asked me for that picture. But yeah, it's a good overview. Thanks, Randall. So yeah, I think we're unlikely to see that people are going to flock to Passetto as OAuth servers, as a token format for OAuth servers, for example. I think some people will implement it, but I don't think we're going to see a massive industry shift to it because I feel like the improvements are marginal, not overwhelming.
Well, stuff in the security space has a tendency to move at a snail's pace anyway, which, it should, obviously. I mean, you don't want to say, hey, here's my cool new encryption algorithm that I just came up with today and have it sweep through the internet by tomorrow before anybody finds any vulnerabilities with it.
Right, exactly. So,
yeah, so I can't see the chat. Do we have any other questions?
Yeah, I'm just looking at on YouTube and Twitch. Nope, not right now. Why don't we talk about the latest in the OAuth group? Because that work has continued to happen as well. We're in the middle right now of our, I think it's 6 in a row weekly interim meetings at the OAuth working group at the IETF, and we have a different topic for every session. Last week was OAuth 2.1. We talked about that last week during this show. This week was 2 specs on the agenda because they're both smaller or newer things that are not ongoing work. One of them was one I presented called client intermediary metadata, and then the other one was from Rafat about multi-subject JSON Web Tokens. So the client intermediary metadata is something I brought to the group last year and have been working with a different standards organization on throughout the last almost full year now. That organization is called FDX, and they are working in the financial industry space with a lot of banks and other types of companies in that world of dealing with financial data, insurance, tax stuff, right? So that whole world with a bunch of U.S. companies, and there's a similar organization in the EU region doing that kind of work. Basically developing a profile, a subset of OAuth that is intended to be useful for that industry. And this is a theme you'll see a lot with OAuth, where it actually lets you do a lot of things, arguably too many things, and in too many different ways. So once you want to apply it to a particular industry, they might have different security requirements compared to other industries. You often want to reduce the number of different options for things. So that'll start being, they'll be like, no more client secrets. We're not going to use shared secrets at all. We're going to only use signing, cryptography for authenticating clients, where you have to do it through mutual TLS or some sort of certificate-based authentication, because that's more secure than a shared secret. So it'll be things like that. And anyway, one of the big problems in the financial world, which is what this group is trying to solve, is that the whole industry is based around screen scraping right now. Like, it's horrible. Like, if you think about how Mint started, banks didn't have APIs. So Mint wanted to be like, oh, we're going to pull transactions from all your banks. Well, how are they going to do it? They have to screen scrape the bank websites. And in order to do that, you have to give your password, your banking password, to Mint, so that Mint can go use your password to log into your bank and then download the HTML and then pull the data out of it, which is just a horrible mess.
Yeah.
And things have gotten a little bit better since then. Like, there are banks that do provide actual APIs now. And, things like Plaid have come along as a sort of middle company that negotiates between the bank's APIs and the end user applications. But most of those still require that you type in your password into these aggregators and use your password to go get the data from the bank's API. And you'll see it over and over again if you use any of these applications like Mint or YNAB or even like QuickBooks or any of these things that are going to download transactions from your banks. Anytime that they put up a dialog that says enter your banking password here, that is a huge red flag, and you should not have to do that. It is completely unacceptable from a security standpoint that is a thing that we have come to allow. And because, again, like, if you have multi-factor auth on your bank, which you should, and oftentimes also security questions, because banks like to throw security questions at you, those websites will then also ask you to like enter your security questions or enter your multi-factor code from your app, which is just a huge, it's basically they're phishing your bank credentials, and you're doing it voluntarily. Yeah. And you kind of just have to trust them that they're doing this and they're allowed to do this. And that is exactly the problem that OAuth was created to solve, which was, let's stop sharing credentials with applications. Instead, let's do an actual OAuth flow so that the password never has to be sent to the application. And finally, there's actual support in the industry for moving to some sort of OAuth system for this purpose. So we are seeing some banks actually now do currently support OAuth already, which is great. And when you go and connect those banks in these applications, you'll see that you actually leave that app, you go to your bank's website, you approve the app there, and then you come back, which is a real OAuth flow. That way, those apps never get your banking credentials, which is good. So we're trying to get more and more banks to support that and adopt that, and hopefully in a way that is consistent across everything in the financial space. So that's what that group is doing. They're creating a handful of their own specs that are basically, they're not recreating OAuth, but they're saying, use these certain parts of OAuth in this particular way, and arranging the parts in a way that lines up with their security requirements. So that's a lot of background on that. In that world, there is that this isn't going to make companies like Plaid go away. Like, that middle aggregator tier of companies that are the ones negotiating with the banks and have actual direct access to the bank's API. Those aren't going away, but they are going to be involved in an OAuth transaction. So when you come to, you go to Mint and you go click connect my bank account, Mint also doesn't have relationships with every single bank. They actually have a relationship with the aggregator, and the aggregator talks to all the different banks. And in the current OAuth world, that sort of additional tier doesn't really exist as a concept, right? We have client ID, which identifies the client that you're using, which is supposed to be the user recognizable name. So you would want the client ID to represent Mint, but the clients are registered at the bank's APIs, and they don't have a relationship with Mint. They have a relationship with this aggregator. So that's the sort of problem, is that the current OAuth model of clients being registered to an authorization server is not how this world works. They have this additional tier of entities that are the ones sort of acting in the middle. So what the spec that I was writing does is it actually establishes that pattern in the OAuth world of you, when you register for a client ID, you can also say, actually, I have this chain of other parties that may also get access to the data when you authorize it, because this isn't just the Mint application. It's the Mint application through this aggregator to this bank. So you need a way for that audit trail to exist, and you need a way for the user to know, like on that consent screen, who are all the different parties that are going to get access to your data. So that's what that spec does. It's like, I feel like it takes a lot of explanation about why this problem exists, and then the actual spec itself is very small. It just adds like one field into the registration call. But it's interesting that it's a very specific problem to like when you have this architecture, although it's not actually specific to finance at all. It's just specific to the like, we just don't see that in the normal consumer APIs of other OAuth servers. So anyway, there was that spec which I presented again. We had some people from FDX on the call as well to sort of explain their motivations for this and why they need this metadata in the registration step. And it was it was a good conversation. I think we left it kind of still needing discussion with the group, and we'll see how that goes. That's gonna happen on the mailing list now, which is, I need to do that probably today or tomorrow. But that's where we left that on Monday. And then the second spec was the multi-subject JSON Web Token spec. And he presented some interesting use cases of when you want to be able to have a JSON Web Token that represents not just one person, but two in some relationship. So that could be the subject of the JSON Web Token is a child, but it's actually their parent who was the one that was issued the token, right? So like, I want to be able to schedule an appointment for my child, but it's the parents can be logging into the system. But when they go and do the action, you want the action to be associated with the child, not the parent. But you need to know who is the one that actually showed up and logged in. And that's where the concept of a single subject JSON Web Token kind of breaks down, because what would you put in the subject, right? Is it the person who logged in, or is it the person whose data is trying to be accessed?
Yeah.
So that was a proposal for one way to do that. And I think, again, a lot of that stuff kind of needs to be talked about more on the list, about like, where are the actual use cases that this would be needed? How are people solving it right now? Because clearly this problem does exist currently, and there is some solution to it, even if it's not the best solution. So what are people doing right now that might be the same or different than what is being proposed? So a lot more work to do there on those two. But yeah, interesting stuff.
Yeah, and I'm just trying to think. I mean, it's interesting because the scenario that you're talking about, like, I want to make an appointment for my child, or I want to access my child's health records.
Yeah.
I need to know that when I go in, and I mean, the resource server needs to know, yes, I'm logged in, but I'm making changes to my child's account information, or I'm making an appointment for my child. That's the one who's going to be showing up for the appointment, not me, even though I'm setting it up. And you could say, well, just create an account for your child and log in as your child and make those appointments. But then there's no audit trail that says, yes, dad made the appointment for little Johnny, or mom made the appointment for little Johnny.
Right. And I think also importantly in that scenario, children can't enter into legal contracts, right? Yeah. And when you create an account, you're technically entering into a legal contract. You're signing up for someone's service. You're agreeing to the terms of service. And technically, if you're under 18, you can't do that. You can't sign a contract. So yeah, you want the audit trail, but you also want to make sure that the parent is the one that's actually legally responsible for that account and isn't just like impersonating their kid.
Yeah. That makes sense too. Well, and I keep thinking about the first one that you were talking about, the intermediary thing. I've thought a long time now, why is it that when I go and see a doctor that they don't have access to my medical records, because my medical records reside with the hospital. And so then I go and see a specialist about X, Y, or Z, and they come to these conclusions, but they don't share any of that information back with the hospital. Now, the
Right.
hospital doesn't know that I went and got my knee scoped and knows that I need surgery. I need to go in and tell them that. But there's got to be some sort of way where, like, if I'm going to see you as a doctor, I want you to have full access to all my medical records that are back at the hospital. So those sorts of things are just always frustrating to me. Like, how is this a problem that we haven't solved yet? Where my doctor's like, yeah, I don't have access to those records. So I don't know when the last time you had a surgery was. So you're just going to have to tell me. Like, okay, I can tell you when it was. I can't tell you what they did.
Yeah, kind of a mess. I do know there's another spec involved in that world, which is called UMA, or User Managed Access. And I don't really know how widely deployed it is, but I do know that it's for specifically those use cases of you as the owner of your data are trying to authorize somebody else to access it. Whereas OAuth is about you trying to authorize an application that you are using, right?
Yeah.
So UMA is about you're trying to let somebody else use an application to access your data. So there's two different users involved, and it's an extension of OAuth, so it's built on the same foundation, but it adds in that mechanism for like two people to be involved, and tickets and stuff move around or whatever. I don't remember how it works, but it's meant to solve that problem of delegating to somebody else.
Very cool.
We have a question in the chat.
All right.
How is Depop useful if developers have to implement it? MTLS isn't better. What issue may I face if I decide to go MTLS? So yeah, this is a good question. This is Depop is still new, relatively new, still in progress. MTLS is technically already an RFC. Both of them are solving the problem of client secrets not being secure enough. So client secret is a shared secret between the OAuth server and the client. And the idea with both Depop and MTLS is the client would have a certificate where the OAuth server only has the public key. So the client can create the certificate, put it even on a hardware security module so that literally nothing else can ever copy that certificate, which is a lot stronger authentication than a shared secret. So the difference between these two, though, is MTLS does this at the TLS layer. It's mutual TLS, which means normally HTTPS is one direction, so the client just accepts or validates the certificate of the server. MTLS does it in both directions, where the client, in order to create the TLS connection, opens the connection with a client certificate, and then the connection is also encrypted with the TLS certificate of the server. So you have certificates on both ends. That way, the server can say, oh, I recognize this is the same client coming back because it's providing the same public key signing this message, this connection. But it's doing it at the TLS layer, meaning when you write code for like making a post request, if you're using a HTTP library that supports client certificates, all you do is you just say, like, here's my key, go make this connection, and then nothing in your application code changes. So you make a regular post request. As far as your like application logic goes, it doesn't really know that this is happening because it's happening down at the HTTP layer. So you can just sort of you can take an existing project and add mutual TLS to it by just attaching a certificate to your HTTP client, and you don't have to touch any code in your application. Depop, on the other hand, is a totally different way of doing it, where you don't do it at the TLS layer, you do it in your application layer. So you actually do have to change your application code to be able to create the signature, put it into an HTTP header, and you'll have to actually modify your code in order to be able to do that. Like, you'll have to make sure that, for example, you can capture the request body that you're sending, because that's what gets signed. So you have to actually build the request body, be able to capture that string, do the signature math on it, and then actually Yeah, it's code you have to write in your application. Obviously, hopefully a library will do it, but it's still application layer code. So two different approaches, and it turns out that both have advantages and disadvantages again. So the advantage of MTLS is the client developer, assuming that the libraries, like the HTTP library supports it, they don't really have to think about it other than that. And the advantage of Depop is actually on the server side. So the problem with MTLS on the server side is if you have proxies, load balancers, that kind of thing, your TLS connection gets terminated there and then proxied back to the backend. And because the connection is terminated, it's difficult or sometimes impossible, depending on your architecture, to propagate that certificate information all the way back down to the backend API. So depending on whether you need it at your backend services, the client certificate, you may not be able to use MTLS, or it's like just impractical to deploy it. So the advantage of Depop on that aspect is because it's application layer, that information, as long as it's forwarded in all the headers to the backend APIs, the information and the ability to validate it is already there by the time it hits the backend API.
That makes sense.
So,
I was thinking it would probably be a nightmare to try and manage MTLS in like a microservice architecture where not only do you have multiple services doing different things, but you probably have each one of those services load balanced. So you have multiple services sharing the workload of doing that one thing. And so managing sessions across things can be really nasty if you're using MTLS.
yeah. And I know that there's a lot of organizations, especially larger deployments, that have flat out said they won't add support for MTLS because of those limitations, because it would just be too complicated.
Yeah. But on the flip side, Depop requires you to write the code or somebody to write the code for the library.
Yep.
And
Yep.
which just introduces another vector of attack and another level of failure or whatever, another point of failure.
Neither is perfect. Yep. The one that I'm more excited about, which is still not anywhere near finished, is the idea of an HTTP signature. And there's been several attempts at this kind of spec for a while now, where it's something that the HTTP client would do. So it's meant to, like, the end goal is hopefully to be built into your HTTP client. Like curl would just turn on this flag for signing this request. And you would give it a private key. It would be able to create the signature at the HTTP client layer, put it into that header. So it's easy to deploy. It doesn't require terminating TLS and that kind of stuff the way MTLS does. But it also doesn't have to be application layer code the way Depop does. So it would also then be agnostic to whatever format whatever requests you're making. Like it doesn't care about the format of the post body or whatever. There's been several attempts at this with varying levels of success. There's several different individual drafts that have been, I think actually one of them is finally now adopted by the HTTP working group. So that's promising. Still early days. It's still changing a lot. However, probably the biggest deployment of one of these draft specs is Mastodon, where Mastodon went and picked it up as their authentication mechanism between servers. So when your server goes and delivers a post to somebody else's Mastodon server, your server signs that request with the server's key. That way the receiver knows it's actually from that server. And they picked up an early draft of one of these specs. So, the current drafts are probably quite a bit different from what they've implemented, but it does work. There's a few problems with the one they picked up, but, it works for the most part. But it's good to see that is, another option, which I think is my favorite of the three. I would like to see that one get more fleshed out and adopted because I think that's the right layer in the stack to put it. I think that TLS is too low because of the reverse proxies and load balancer issues. And I think Depop is too high in the application stack. And I think that HTTP signature layer is the right level for that to exist at. Yeah. Interesting stuff. David says, Lee, isn't this what a service mesh is supposed to alleviate, making managing MTLS easier?
I suppose. I don't know a whole lot about service mesh. I've only messed with Azure Fabric, whatever the hell it's called. So there's a lot of magic going on there that I don't even know like how it does it. So
Okay.
Azure Service Fabric, that's what it's called.
Okay.
And just like everything else, we call it service mesh and we think about this cool netting thing. And really, it's just a bunch of computers that are doing work for us, right? So trying to figure out exactly what those computers are doing is the tough part. Because most people don't want to know. They just want to know, hey, here's Azure Service Fabric, and I can put these servers out there, and the mesh, the network mesh will deal with all that. But there's something going on a CPU somewhere when it's managing those. So I'd be interested to find out how that actually works.
Yep. Well, cool. We're about at the top of the hour. Why don't we wrap up here? I think that was a good conversation. Covered a couple of good topics today. The next Monday will be another OAuth group meeting. Again, if you want to go find upcoming meetings, that's events.oauth.net. So that is where you can actually go and see the list of upcoming sessions and also upcoming sessions, upcoming meetings, other workshops, relevant things. Next week, we're talking about RAR, which is rich authorization requests, which is a fun one. Also very useful in the finance world, but has applications much more broadly as well. And we will be back here on Thursday after that for a discussion about that.
So have we actually gone far enough past WinRAR that we can actually start using RAR as other acronyms now?
I hadn't even made that connection. That's great. Oh, and of course, next week is Octane. So a lot of good developer track sessions there. I have a session. Do you have a session, Lee?
No.
No, okay. But you are going to be hanging out in the chat.
Yeah, I'm helping out with the labs and helping answer questions in the developer hub.
Yep. And you can find all of the developer events at Octane at octadev.events. And you'll see all of our team's talks there. And there's also the developer day, which will be Friday, which will be fun. A whole bunch of discussions. We're going to do a broadcast of the actual lab sessions that they're running on Friday, and then also come in and do demos, live demos, Q&A like this, and we'll be running basically all day Friday. There'll be stuff live to watch on Octadev TV. So with that, thank you all for coming. Thank you for watching. Thank you for bringing questions. And with that, see you all next week.